Hi guys, so today we will be integrating a circuit breaker with our microservices. So if you have come to this channel for the first time, so you are at the right place. So we are learning microservices with small examples which are easy to understand. And if you like the videos, please hit the like button and subscribe to my channel. Let's get started. So let me take you to the current project setup first. So we have two microservices which register in the Eureka server. We also have an API gateway. We are not looking into this today. We have already seen this in our previous video. So these two microservices, so we have this employee microservice which connects with the department microservice via the REST template. So, and yeah, so why do we need a circuit breaker? So let's see that quickly. Consider we have these our two microservices. One is the employee microservice, which is connecting with the department microservice to fetch some data, as we have seen. So now when it is connected, let us consider this as a closed circuit. Okay, this is closed and the both services are up and running fine, and then there is no problem in the system. So now suppose this application goes down, then what would happen is this would be sending the request, but there would not be any connection with the service as this is down. So the load on this one increases, and because of that the other services which could be trying to connect to this will not be able to connect because of the load, and then it would be like a domino effect and the entire application would go down eventually. So to avoid that, what we can do is we will make this as an open circuit. Okay, instead of connecting to this, we will make it as an open circuit, and then we can call a fallback method. Or if there is any cache, we can retrieve the data from there. Some kind of fallback we can implement. Okay, but till when we will be in open state? So for that we can have some configuration setup wherein we can go to a half open state. Okay, so we can go to a half open state wherein some requests would be allowed to try to connect to this microservice, and if it is able to connect, then it will again close the circuit. But even in the half open state where we are allowing some limited number of requests to try to connect to this microservice, if they are not able to connect, then again it would go back to the open state. Okay, and then yeah, so all these configuration, all this how much time to be open, whether it will move to the half open or not, everything can be configured. So we can do this configuration via the properties file or the YAML file or the Java based code based configuration. So these examples you will get a lot. So there is no much information about the property configuration for these circuit breakers. So let us look into that. Because it is a little cumbersome, so it is not available, but that's okay. We will see how to configure using the properties file. Okay, so I have the properties here ready. So we will go through each of them one by one. So we will add these properties to our employee service application.properties. Okay, so here the first property, if you see, it is the shared one, and we are saying the register the health indicator, and we are setting as true. So what is this health indicator? So as we have talked in the last video about the actuator, so where it has the health endpoint. So here we are saying this circuit breaker to register with that health endpoint and show the details of the health status of this circuit breaker. So there we are registering. And then failure rate threshold. So we will have a failure rate threshold as well as a slow rate threshold. So failure is when the request is completely failing. So here let us make it as 10. So this is like a percentage. So suppose out of 100 requests, if 10 requests are failing, which means the failure rate is 10. So the circuit will open. And we will also have a slow rate threshold. So not just the request not being responded, if the requests are too slow, if they are taking a lot of time to execute. So suppose we configure that as 10 seconds, and if the request is taking more than 10 seconds, then that request will also be considered as a failed request. And then minimum number of calls. So this is minimum number of calls which have to be there to be able to do this calculation and decide whether to open or close the circuit. And then sliding window. So sliding window is nothing but if I explain you. So sliding window we will have two types. So one is the count based. So suppose we have 5 requests and our sliding window size is 5. Okay. So it will do all its calculation of threshold and all for these 5 requests. Okay, so when the next request comes in, this sliding window will move and then it will consider these 5 requests. Okay, so this is the count based, and we will also have a time based sliding window. So for the 10 seconds based on our configuration. So if we have some n number of requests, so it will then the window will be based on the time, not the count. Okay, and then the next second, so it will take the request and find out whether they were successful or not. So this is the sliding window. So here we have the sliding window size as 5, which means, and we have taken the type as count based. So the 5, it will take the 5 requests. Okay, and wait duration in the open state, and these two will go hand in hand, we can say. So it will transition from open to half open state, and we have enabled that. So after 5 seconds, it will automatically go from open state to half open state, and the number of calls it allows in the half open state is 1. So we can, so even if we don't configure this, we can go with the default values as well. So there are default values for these parameters. So here we are saying in half open state, we are just going to check one request. If it is successful, we'll close the circuit, or else we'll not close the circuit and it will go back to the open state. And then max wait duration in half open state. So we will wait in half open state for 5 seconds. So these are all the parameters for setting up the circuit breaker. Now we have to define the give a name to this instance of the circuit breaker. So let us give it as department circuit breaker, and then we have taken the base config as shared. So these are all the properties which are for the shared configuration, and it can also be a default configuration. And then these properties are for the actuator. So include asterisk means all, so it will include all the endpoints available, or we can just make it health as well. Let us put it star for now. And then health show details. So if we do not give this, then it will not show all the details, it will just show that it is up. Okay, and then enable. So we are enabling the circuit breaker functionality for the actuator to consider the circuit breakers and display their health status as well. So this is the application.properties file, and we will also need the dependencies. So for that, let's go to the start.sprint.io. So I'm not creating any project here, I'm just taking the dependencies, circuit breaker as well as the actuator. Okay, Okay, so this is the Gradle. I need the Maven dependencies. Okay, so I have taken this and I will add this in the form.xml. Let's add it towards the end. Okay, and I'll just update the project. Okay, so this is done. And one more thing is we'll have to add the annotation and we have to tell which circuit breaker it should be referring to. So the name of the circuit breaker, so we'll take the name directly from here which we have given, that is the department circuit breaker, and then the fallback method. So we'll have to give the fallback method. So let's name it fallback method itself. And okay, I have added it at the right place or a wrong place. Okay, that's okay. This is also calling the department microservice. So we will define the fallback method. So let me copy this name so that I don't make any mistakes. And then it will take an exception, throwable implementation it will take. And here we'll just return some string, something like this is from the fallback method as the department service is down. And let's just add the message. Okay, so this is done. So let us quickly start our Eureka server, the department service application, as well as the employee service application. So we will go to our Eureka server, which is running at port 8761. Okay, I will also show the port numbers. So this you might have seen already. This is the 8081. The employee microservice is running on port 8081. And the department microservice is running on port 8082. Okay, so let us see if the Eureka server is up. So our Eureka server is up and the microservices have not yet registered. So we have this department microservice registered. Let's wait for the employee microservice as well. Okay, so now we have both our microservices registered. So let's quickly see. 8082 is the department microservice. So as you can see, we have some data, and let us see the same from 8081, which is the employee microservice. Departments. Okay, we have the same data. Now what we will do is, okay, we will see the actuator as well. 8081 we have added. As you can see, the circuit breaker details are displayed. You can see the status is up. The failure rate is negative because everything is running fine. Threshold is 10%, which we have defined. Slow call rate is also negative. This we have not defined, so it has taken the default 100%. The buffered calls, only once we have called the department microservice. And then everything is successful, so all these values are 0 and the state is closed. Now what we will do is, we will make this department microservice, this department service application, we will stop it. Okay, now I have stopped it. So now if we try to call from 8081, which is the employee microservice, okay, as you can see, the connection is refused, so it is the fallback method is triggered. Now if we see the health endpoint, you can see that the two calls are buffered because one was successful, one was failed, and the circuit is still closed. We are still trying to connect to the microservice, but we are getting the connection refused. And then again we are trying to connect. So here we got 3 calls, and now the failure threshold, failure rate has gone to 66% because out of the 3 calls, 2 calls failed. So the percentage has gone beyond 10%, which is 66%, and then the circuit is open. So now if you see, so now after 5 seconds, if you see, it goes back to the half open because we have configured 5 seconds in open state. It will go back to half open and it will allow just one call. It will allow just one call. So let us see now. It is still in half open state. Yeah, so is in open state and does not permit further call. So whenever it is in open state, it does not allow to connect to the microservice. Okay. And every 5 seconds it will go back to the half open state. If you see, so again it has gone back to the half open state. And the fallback, we are still executing the fallback method itself. Now it is in the half open state and it doesn't permit the further calls. So in this way we can restrict to the microservice to connect to the service which is down. Okay. And then now let us bring that department microservice back up again and see if the circuit gets closed. So this is starting up. So this is the department microservice which is starting up. Okay, so it is up. Let us wait for a couple of seconds. And then it is in open state, so it doesn't permit, it doesn't try to connect. So we have to connect it when it is in half open. So we have probably connected when it was half open and then it was able to connect, and now the circuit, if you see, it will be a closed one. So in this way we can prevent the domino effect of our entire application going down because of just one service being down, and then thereby increasing the availability of our application. So if you like this video, do hit the like button, and if you have any questions, do let me know. Thanks for watching.